Hello, students. There's some work that I have given your class rep, and I hope he has already shared it on the wall. Uh, this work is on technical drawing. The topic is uh, orthographic projection stroke isometric projection, because as we had agreed before, that we are going to tackle the two topics concurrently, because they borrow a lot from each other. So as we look at isometric drawings, we also look at orthographic drawings, so that we are able to draw. Given an orthographic drawing, you are able to convert it to isometric, and vice versa. uh, you are able to do. um, so I have given some work to the class rep, and I thought it wise that I should give an example of how it's supposed to be done, because most of the times students get lost when they are given some work without proper instruction on what they need to do. So particularly this lesson is about how to draw a pictorial uh, drawing from an orthographic one. And I think I have introduced in class orthographic drawings and isometric drawings. So some of the isometric drawings that we have looked at is, some of the pictorial drawings that we have looked at is isometric projection, oblique projection, and axonometric projection. If you remember, in oblique we have cavalier, and we have two oblique projections. But in this lesson, I want us to just look uh, uh, at the work that I have given you, and to be able to draw in isometric projection. So isometric projection is what we want to convert all these orthographic projection drawings to. And we have a number of them here, starting right from number 4 and up to number 15. And figure 1 to figure 15 shows three views. That is the front elevation, if I may point to that as front elevation, and then end elevation for question number 4, and the plan. So you can see that number 4 has three views of orthographic drawing, and all the other drawings have the same setup, where you are given three views: front elevation, end elevation, and plan. Front and plan, front and plan. Yeah, how do we know that this is front elevation? Because the plan will always be, if it is first angle projection, because all this is drawn in first angle projection. If it is first angle projection, then we shall have the front elevation being on top of the plan, or the plan being below the front elevation, in all cases of first angle projection. So we know all this work is in first angle projection, and we want to draw it and fully dimension it in isometric. Then another thing you have to be keen about is this F over here. Yeah, it is in all these drawings. F is a point, the lowest point in that drawing when drawn in isometric projection. So F will be the lowest point of the drawing when it is drawn in isometric. When it's drawn in orthographic, you may not actually realize the lowest point, but it will be very obvious when you put it in isometric projection. So let us tackle number 4. And looking at number 4, you can see the front elevation that has taken the shape of a H. And then we have the end elevation that is a rectangle. But also notice these dots, meaning that there is a depression. Yeah, these dots show this depression. When you look at it from the top, you can see that this is a depression. This part is lifted and this part is lifted. So the lifted part is this one, and the other lifted part is this one. Notice that the lifted part has also another part which is the lowest. That's why we have the F here. So the lowest part is this, yeah, and we have another part which is on the lower side. So to draw this, we first of all have to draw the isometric setup. We have to draw an isometric setup, and an isometric setup is simply a horizontal line. You draw a horizontal line and then have this as 30 degrees. This one as 30 degrees. Remember, we are drawing in construction lines. Yeah, they may appear here to be finished, but these are all construction lines. So we have this at an angle of 30 to the horizontal, and this one also at 30, and this at 90 degrees. I hope each and every one of us is able to draw this setup very easily. You can use your t-square together with your set square, 30 degrees set square, and it will be able to give you this very easily. So once we have drawn that, now we are starting to identify the sides so that we can place it, map it on that 30 degrees isometric setup. And the first thing we notice is that this H is now placed on the side. We are assuming that the whole object is tilted at 30 degrees to the horizontal. So we can see that this H appears on one side. That would mean that if this is the front elevation, and the end elevation has to come on this other plane. We have this plane and we have this other plane. So since the front elevation has been placed on this plane, then the end elevation will have to come on this plane, and therefore we can take this rectangle and place it right there so that it connects seamlessly to this one. Yeah, you can see now that it has been placed. This rectangle has been placed, but we can still see these dotted lines, and the dotted lines simply show that although this may be long, this rectangle may be long, but at some point there is a step. There's a step, and that step, since it is not exposed, we can see it as dotted. Yeah. Then after that, we now need to place this plan, and the plan shows the top here. You can see that there's a small rectangle here which is indicated F, and that rectangle will be right here. Then there's another rectangle at the end. That rectangle will come here, and we have a longer rectangle here, which is this depressed place, this depressed place, and therefore we are going to have a rectangle here, another rectangle there, but at an angle of 30 degrees because the whole thing is in isometric angle. So let's see how it comes. Now there it is. This rectangle is this one is the first one, which is written F. Then we have this other one which we have not yet demarcated. We have to remove this line, so it means that the lines you draw need to be in isometric, because if you erase lines, you might find your work becoming very untidy. Therefore, we draw in construction lines, which if erased may not actually be interfere with your work. And sometimes we just leave them in position just to make the other lines finished, and your work will be nice. So we can see that this part and the other part, uh, this part and this part already are there. So we need to erase these lines, erase this one. But in your case, because you have drawn it using construction lines, you may not need to erase it. And then probably finish this. There's a line here that we may need to draw. And now you can see as we finish erasing those lines, the H is very prominent here, this H. And then this I, this rectangle here, is also very prominent here, but without dotted lines because we are not looking through it. And then you can see the other parts now that we need to put together. Just pull a line down here and then pull one here. Uh, and one thing you have to be very keen about is that these lines are parallel to each other. So any line that is moving in that direction must be parallel to each other. They must be parallel to each other. Any line that is vertical must be parallel to each other. That's how you prove that your diagram is actually right or okay. Each line which is running in the same direction must be parallel to each other. So you can see now the finishing line. We have that one, we have this, and then at the junction here, then we can pull another line here which is parallel to this, and this line here is parallel to this, and it's also 30 degrees to the horizontal. And if you look at that, now this is complete. This is the complete diagram that we need to draw. So if we were doing it, if it was scaled, then we would have now done the dimensioning. We would have pulled the dimensioning lines here, and we would have done our dimensioning. Otherwise, this is a freehand sketch diagram. You do not need to measure, you only need to make it proportional so that if this okay, if this part is longer than this part, then it should appear so. If the width is shorter than the length, that should also appear that way in your diagram. So that is how you can draw this orthographic drawing and place it onto isometric drawing. So I think we shall look at more examples after you have done your work. Next time we meet, we shall be able to look at the whole of this work and see how much that we may be able to do. Otherwise, thank you for watching, and please try to think out of the box and you'll be able to do it. So have a lovely day.